Hey YouTube, welcome to my latest episode. Today I'm very excited to introduce to you the latest stealth game series. This is a reboot from the old series, but it has more episodes, more content, and everything is much better. It has custom player control scripts and heaps of stuff you can take away. It has more experience on my side, and it's just going to be a whole lot better. So today's episode we're going to be writing the player controller, starting off quite basic. We're not going to be using Unity's CharacterMotor. We're going to be writing everything ourselves, from slope detection to jumping to everything is our own. Okay, so this is going to be one of the longest episodes in this actual series. It's going to be taking quite a while, so you better strap in. If you do not have the time to be writing this code, all of the code that I write now will be in the description where you can download it. Okay, let's get right into it. First, I'm gonna just open up a blank project for you guys, and we're gonna set up a scene. And I'm just gonna save this scene as player testing, because we're gonna have a scene just for testing. And as I create new content, I'm just gonna be organizing it in to their respective folders. So let's create a scenes folder and put that in there. Okay, now we're gonna set up the scene. We just want a little area to test our player controller. So basically this player controller is going to be similar to my player controller that I made on my channel previously, but it has tons of new features and better collision detection and stuff like that. So this episode is mainly for the player controller. You can skip ahead if you already have an FPS controller, but I'm gonna add stuff as like ladder climbing and etc., which would mainly work with the player controller I'm making now. So let's get right into it. So create scripts folder. Okay, we have a cube. It's looking quite plain right now, so let me add another folder. Let's call this materials, and I'm gonna go in here and add a material. Let's call it ground material, and this oh, I need to learn how to spell material. Okay, so this series is actually has heaps of content. I'm gonna be teaching heaps of AI stuff mainly, and it's gonna be very advanced. Last time I used the Rain AI. This time we'll be coding the AI by ourselves. So the field of view for the NPCs, everything like that, we'll be coding on our own. So here we have the ground. Okay, we got that set up. We're just gonna do two things. We're just going to duplicate the ground and slide it across and just rotate it. This is to make sure our slopes work fine, because we are going to have slopes in the game. And then I'm also going to add a bunch of cubes to test the collision. That's the main thing as well. Collision, we need collision. And really, I'm sorry about my fan, but I'm getting a new computer very soon. It has latest specs, so you won't be hearing my fan in my future episodes. So if you stay subscribed, I have heaps of content planned out, like sorting algorithms and everything. It's coming. It's coming. Everything's coming. New Year's resolution: create heaps of videos, basically. Okay, so let's duplicate this material and call this obstacle material. Just gonna make stuff look decent. Alright, just gonna drag this onto here, here, boom. We have a little scene set up. Okay, 3D object capture. I am gonna warn you, this character controller is gonna get quite complex. It's basically how Unity's character controller works. So the character motor that you would attach onto a script, it has heaps of stuff being processed in the background, raised sphere cast. Basically everything that the character motor does will be doing in this bad boy here. It's not 100% perfect, but it has heaps of amazing features like working with terrains. So terrain traversing, very easy with this. I'm very happy to announce it. I've been working on it for a while, so here you go. Here it is for free. Let me just make all of those. Oh no, that was a very smart idea. let me just create an empty and drag these cubes and stuff in there. We'll just call this level, and we can drag the directional light in there as well, and we'll just put that up there. Boom, easy. Alright, and for the series as well, I will be creating the level and everything. It's gonna be a fully fledged game. It's gonna be amazing. Alright, so capture. First, I would like to set up the camera controller. Okay, so first we're gonna set up the camera controller. It's gonna be a third-person controller. So basically, you'll be able to rotate around the player like so, and you'll be able to move the player and climb slopes and collide with stuff. Okay. Let's just call this camera controller. I'm going to be moving quite quickly because this is going to be a long episode. Let's go into our assets, drag our camera controller into our script, double click scripts. Oh, hurry up. Open the camera controller, wait for it to load. Okay, here we go. Okay, camera controller, and let's get right into this. This is kind of from the Unity forums because this is very nice, and we will extend upon this controller, but it's not mine. I'm just gonna say this is not mine, but it is extremely useful, and I just use it for prototyping. But we will be extending on this camera, especially for collisions. We'll be making sure that the camera will collide with the walls, etc. But we're not going to do that right now. We'll just work on the actual character because that's a big enough project on its own. And the default values I will set, and we'll create a public transform target. That's going to be our capsule. Okay. Public float distance from target. I will explain how this script works as I write it. Okay, just because I got it from online doesn't mean I don't know how it works. So public vector2 pitch min and max equals new vector2, and these are the default values. Okay, public float rotation smooth time, basically the dampening of the camera rotation. It actually looks very nice. Rotation, smooth velocity, and this is just a vector3 and current rotation. Alright, float gear and float pitch. Okay, private void start. You don't have to do private void. I'm just obsessive about that and it looks nice, so I just put that there. If lock cursor, then cursor.lock state equals, cursor mode locked. So basically, locking the cursor is when you're in the game and your cursor disappears. So your cursor won't come outside here. So when you click to shoot or whatever, you won't be interacting with the inspector or the hierarchy. So basically, that's what locking does. It's pretty useful. Okay, cursor visible equals false. You can keep it like, there if you want. I don't know why you would, but okay, we're gonna set this to a late update. I'm pretty sure on the forums it is an update, but I don't know if I changed that or not. I did modify this just a bit to help with my character. Get axes, mouse X. So this is you moving your mouse horizontally times mouse sensitivity, and a pitch will be equal to input.getAxes, and you guessed it, mouse Y, and we're going to times this by mouse sensitivity. I'm sorry that I'm moving so fast. I have to do this, and we're going to clamp this. We're going to clamp the pitch so we can't go too far off up and down, so we can't just go like all the way down and do a 180 and come back to where we were. Won't look good at all. So we're gonna clamp the pitch to pitch. Where is it? Oh, whoa, I spelled this wrong. So, quick tip: if you're on Mono Develop and you ever spell a variable wrong, right, and you've used the name like 20 times throughout your script, and you want to go through and change it, let's right-click here, click Refactor, click Name, rename, and then you can just change it, and it will change everything in your current script and in every other script that uses that variable, which is it's one of the most useful things I've learned. So, we're gonna set the min and max to the x and y, so it's just a hacky way of doing that. We're gonna set the current rotation to vector3.smooth the damp current rotation. So smooth the damp is basically something like a lerp, but it's for this purpose, if you get what I mean. I hope you did. Okay, we're gonna smooth damp from current rotation to a new vector3 to the pitch and the yaw and ref rotation smooth velocity. Reference that one, and the smooth time we're gonna go rotation smooth time, easy stuff. Now we're gonna set the transforms Euler angles to the current rotation. Actually, that Euler angle, it took me a long time to get the pronunciation right. Alright, transform the Euler angles e dot x equals 0. This bit is my own code because this is to rotate the actual player in the way that the camera is facing without rotating the player up and down. So this will make sure that the player, right, only rotates in this axis, okay, and not in this axis. And it will always face the way that the camera is facing. So we're going to set the target's Euler angles to E as well. I mean, not as well. And then we're going to set the transform.position to target.position minus transform.forward times distance from target. Okay, so this will basically push us backwards from the distance that we are specifying. Okay, so we have all of these variables here. I actually want distance from target to be around 8 or so. 8.5 should be fine. And when you click play, boom, you have this little script where you can rotate around the player. And as you can see, if I face this way with my camera and I go around here and click on this, and click local, we can see that it is facing this way. So if I turn like this, okay, here we go, pause that, little shortcut, you can see we're facing this way, and that will just help heaps with our player controller, because we're always facing the direction of the camera. And I really like this script. You could just copy it straight off the thing because it's amazing. I really like it. Okay, now to get down to the real stuff. Okay, I can make mistakes on this because I'm not really going off of anything, but this is how it works. So that's right, player controller. So this is not going to be one of those scripts where you feed in a force or a direction and it moves. This is just a full controller that handles input, movement, slope detection, collision, everything in one script. I'm not sure this is the best approach. You can change it if you want. It's actually quite easy to change, but I'm not used to that and I don't want to mess up now, even though I probably will mess up anyway. Okay, where are you? There you are. Oh, I can hear my fan starting to enter into this. Okay. First order of business, just getting the basic movement out of the way without gravity or all of that other boring stuff. Okay, so let's create the most important variable, movement speed. And I'm going to tell you, this is not going to be 100% fully fledged player controller. I will improve the player controller in a separate episode where I'll write the full heaps of lines of actual controlling code that polishes the movement and everything, but this is not going to be 100% perfect. If you want, you can still use the Unity's custom CharacterMotor, okay? But this is my way of doing things. I like doing it on my own. Alright, firstly, let's just create the update function. Okay, and then we're gonna set the velocity. We're gonna get some private, ooh, that's not exactly what I wanted. Private variables, and in private variables, I would actually like, oh, okay, sorry about that. I would like a private vector3 called velocity. Yep, that sounds about right. And private vector3 move. Private, that should be fine. And this is right. Yeah, okay. Now what we're going to do is we're going to create another void called simple move, and we're going to create another void called final move. Alright, so basically what's going to happen, the flow of this script, is it's going to run all the methods. So simple move, gravity, collision, everything, and all of that will accumulate and then get pushed into the final move where the player will move. Okay? Yeah, okay, so we're going to write that. So we need to make sure our methods are in a specific order when we write these scripts. Okay, simple move, easy, let's write this. Move is equal to new vector3 input.get axes horizontal. So this is basically our left and right keys. Yeah, okay, easy. And then we're going to write 0 here because we don't want to move on the y-axis just yet. And input.get axes vertical. This is 100% my script, so and you can use it however you want. Yep, okay, movement speed. Alright, that's basically it for that one. Yep, okay. And then move, oh, no, velocity is equal to new vector3 move.x. Move, no, 0, move.z. You might not understand why I'm doing that just yet, but we are going to use this line for more than just that. And I'm going to remove this times movement speed here, because I just remembered this has to go at the end. And we're going to do velocity is equal to transform direction, and we're going to go velocity. So always make sure the velocity is facing the forward way, so it's relative to our forward, so we're always moving relative to our forward direction, if that makes sense. And then we're going to go transform.position plus equals velocity times time delta time, and if we play this, it probably won't work because I probably messed up somehow and I don't know how. Let me just check. Let's set a movement speed of 5, and oh, it works. Okay, so as you can see, we have very simple movement, no collision, and we probably don't have slope detection. And let's get on to the next order of business, which is probably the gravity. Gravity sounds fun. I actually remember I need to make this in a proper order, or none of it will work. Okay, so let's make gravity. This can be the movement vectors, and let me just section this off because I like my code being nice and neat. So we're gonna do hashtag region. This is really useful if you don't know what this is, because this just made my life a million times better. So methods, and we go down to the bottom and we go end region, and as soon as you do that, you can fold the code. Wow, right? You don't even need a method to fold it. So fold it, make it nice and neat. Wow. Okay. We're gonna do another. No, we don't need a region yet. Okay, so gravity needs to be handled at the top. Private void gravity, and let's get the gravity variables. Actually, I can declare these right here and then section that off. Oh my god, I hate it when that happens. Sorry. Gravity private variables, private grounded, and oh, that's it. Yep. Okay, and we're gonna do something called I don't know what I'm doing. Okay. What am I doing? Alright, sorry. Yep. Okay. Private float current gravity equals 0. Okay, so if we're not grounded, the gravity will increase. If we are, the gravity will be set to 0. Whoa, easy stuff. Okay, and we're going to create a little header here called movement options, and I'll basically control our movement. We're going to create another header called gravity. Another way to make your code really neat. So there we go, that's the original gravity. So I'll set this to around 3 to 2.5. Okay, we don't want the gravity to be too high just yet because we don't have ground snapping yet. So if it's too fast, it'll just clip to the ground and never come back. So yeah, we don't want that yet. If grounded is equal to false, then the current gravity is equal to the gravity, and else gravity is current gravity is equal to negative. No, is equal to 0. So if you're not grounded, then it will be set to the original gravity, and if you are, the gravity will be set to 0, so we won't be affected by gravity anymore. Okay, so let's go into update method, and at the top, let's add gravity. Okay, and in our final move, let's go to our velocity vector, and here we will just do negative gravity. Okay, and why would I do that? Why would I do that? So negative current gravity. So the higher this is, the faster we fall. Easy stuff. We won't be seeing an effect of gravity yet, obviously, because we haven't set our grounded. So I'm just going to start the next thing. I'm just thinking about how I want to do this because I don't want to make it too complicated, but we do need reliable grounding options. So just thinking about how I'm going to do this, because my current solution is to send a sphere cast down and then send a ray cast down and then check the sphere on the ground, and has 100% reliability. And the script for my actual player controller I will also leave in the description. It has all the features, and this is just a simpler version. I'll leave a link to this as well. But I don't know how I'm going to do this. I know I need to do ground checking after, so let me just add that in. I will do a sphere cast. Okay, I'm gonna teach you guys how to do a sphere cast if you don't know already. Okay, sphere casts are really useful. I won't be putting much of the variables in. I'll just hard code the variables in, which I think are the best for this game. Okay, but if you really want the full script, it will be in the description. But this is how I'm gonna do it. So we're gonna declare a new array. T point. Another quick tip. Whoops. Sorry. Another quick tip. If I'm talking too slowly or going too slowly, just edit the speed value on the YouTube video, and it should be fine. So we're gonna create a new vector 3. I'm sorry. Okay, we're gonna create a private vector 3, and we're gonna call this lift point because new vector 3, and we're gonna declare this vector here. So we're gonna do 0. And we're going to go 1.20. We might need to edit this later, but this is basically a point slightly above the player where we will, where it will send a ray down from there. We want that, especially because if we're on a slope, we don't want to be sending a ray from here or here. We want to be sending it from up there so it detects the slope at any given point. Okay. Now that I have that out of the way, let's go into this, and we'll go transform point, lift point. We need to make sure that the lift point is relative to the transform's position. Okay, that's all good. The direction should be vector 3 dot down at all times, and very important, physics. So let's just go physics, and let's go public layer mask disclude player, and let's add a layer to the player to make sure when we are casting down from above, we are not actually colliding with the player itself, and then the player thinks itself is the ground and it just dies. Okay, we don't want that. So we're gonna go and add a layer. We're gonna call this player, and we're gonna go back to the capsule and add the player layer to the layer. That sounded awesome. Okay, now we're gonna go physics, disclude player, and we're gonna click on everything, and then we're gonna uncheck the player. Wow, okay, now we have a layer mouse set up. Oh no, that was one of the, no, okay, now my computer's actually gonna die. Oh god. The one reason I use MonoDevelop is because I'm recording. Okay, okay, let's call this raycast hit, and we'll call this temp hit, and I'll tell you why in just a second. And we're gonna create another variable called private raycast hit ground hit. This is really important. It just sets it tells our whole script what the ground is. It's normal. It gives every value about the ground to the script, which is extremely useful. Okay, now we're gonna go if physics dot spherecast ray lift. We're gonna set a radius, and we're gonna go around 1.57. And I will turn this into a variable later if we need it, but for now we don't. I'm going to go out temp hit, I'm going to go around 20, and disclude player. Okay, you can see I'm hard coding much of these variables, but in my script that I put in the download, in the description, most of these values, from this to this to this vector, everything is a public variable that you can change, which is amazing, but I don't want to turn this into really complicated stuff. So grounded equals false. Okay, if we are above 20, it's grounded by default, so it's false by default. But if it is lower than 20, we want to make sure that we're actually near the ground. And if we are, we need to make sure we snap to the ground, because that is exactly how the slope climbing works. Without that, we don't have slope climbing. So basically how the whole slope climbing process works for most games, and mine, is what happens is we imagine we're standing. Oh, let me visualize here. It's 5 o'clock in the morning, and I woke up at 4 to do this. Really tired, sorry about that. But here we go. If we are here, for example, our ray comes down, and it hits the slope, and we automatically get snapped to this position, for example, right? And then we move forward on our keyboard, and then our ray comes down again, and it detects the slope is here, so we get pushed up. But since this happens every frame at a really fast rate, we won't even notice the changes of you snapping in and going up. So basically this is the movement that's happening, but you won't see that, neither will the player, unless they have like a toaster. Okay, so let's get into the slope detection stuff. Okay, private void ground confirm, and we're gonna go raycast temp hit. So we're gonna get a new method called ground confirm, and we're gonna pass in a raycast, which is the ground. So we're gonna go ground confirm temp hit. Okay, so if it is below 20, we're gonna make sure we can confirm with the ground that we're actually hitting. Okay, so what we're gonna do is one of the most important things. We're gonna go float current slope is equal to vector 3 dot angle temp hit dot normal vector 3 dot up. And this method that I'm gonna write now is gonna be really weird and complicated, but I'll try to explain it to the best of my ability. But it's gonna be really long. I'm just warning you, a very long method. You can break it up if you want, but it's gonna get messy. Okay, current slope. Okay, so basically how we detect the slope of any surface is, imagine this is a surface. I hope you all know what a normal is. Normal is basically like the direction that the face is facing. Okay, yeah, but basically that. So the face here would be facing outwards in this direction, and then we get the up vector, and since we have these two vectors, we can get the angle between them, and that's our surface angle. Basically, that's how we calculate the slope. So we can use that to make sure that we are always climbing the slopes that we want to climb. Okay. Actually, I'm actually thinking about this. I don't think I need any of this, if I'm being honest. Yeah, I really don't. I can try write it without the slopes, because for our purposes we don't really need it. That would be going way too in depth. But let me just write this without the slopes. If we need it, then I will add it in later. Okay, so what we're gonna do is we're gonna write another private vector 3 called ground clamp. Okay. Actually, I'm sorry, we don't need to say that. I'm sorry. This is just really complicated script, and I'm just trying to make sure you guys are getting only what you need. Alright, so we're gonna write the. We're gonna make sure we're hitting the ground. Okay, that's what we're gonna that's what we're gonna start off from. So we're gonna add a new collider array. We're gonna call this collider, and we're gonna give it a buffer of 3. Okay, and what we're gonna do is we're gonna go int num, so num, and we're gonna go if physics dot overlap sphere non allocate. Okay, so this is a more efficient way of just setting this to this. Okay, it's a better way of handling things. And we're gonna set a new vector 3, private vector 3, ground checkpoint, because new vector 3, and we're gonna set this to around 0, negative 0.87. Okay. So basically, there will be a little sphere. We're going to get an error now, but that's fine. There will be a little sphere just below the player with a big radius to always make sure we're hitting the ground. Okay? If we don't hit that, then obviously we're not grounded. Okay, so we're going to set it at a transform point ground checkpoint, and we're gonna set it to a radius of, we'll set it to 0.57f, and that will be a public variable inside my other script as well. I'm really trying to do this right, and we're gonna get the results into code, and we're gonna pass in the layer of disclude player so we make sure we don't hit ourselves again. Okay, now basically how this is gonna work, we're gonna set grounded to false. Okay, and then what we're gonna do, we'll just go down, and we're going to make sure that we are grounded by checking for the ground in our collision buffer. So basically what we're going to do is going to loop through the collision buffer. So for we're going to write a normal for loop. I is lower than num, and I plus plus. Okay, now if, let's get rid of that, if call I dot transform is equal to temp hit dot transform. Okay, so if the collision transform is equal to the same ray cast transform, so we ray down and we find this ground, right? And this is our temp hit ground, and we do a collision check on the radius. If it's equal to the same thing, then we are grounded. Basically, that's the concept that I'm trying to implement here. Okay, if this is the same, then ground hit is equal to temp hit. We're gonna officially make that our ground. And we're gonna set grounded to true. Well done. We're on the ground. Now here is the fun part of actually snapping the player to the ground. Okay. Okay. I'm sorry, I'm really sick. Okay, what we're gonna do is we're gonna add a public void called smooth, and we're gonna add a public void called smooth speed. Okay, so these two variables are important, so I'm gonna make those public. Okay, so if not smooth, then we're gonna clamp it directly to the ground. It could be very jittery or it could be very smooth, okay? But if it is smooth, then we write a separate method for that using vector3.lerp, okay? I don't think I'm using lerp correctly there, but I don't want to make this too complicated. Like I said, I only have a limited time to do this, so let's get started. Okay, so what we're going to do is we're going to set the transform.position directly. We're not going to be using a velocity somehow, okay? So we're going to create a new vector3 transform.position.x and ground hit.point.y plus player height divided by 2. Okay, so this is going to be another option here. So we're going to create a header. We're going to call this player options public float player height. Okay, so this is going to be a public variable that describes how high the player is. We can set that with us ourselves. So we're going to player height divide 2. Okay, and I'll explain this just a sec. Let me do that. Okay, so if it's not smooth, right, we're gonna set the player's transform position to its current transform position.x, current transform position.z. But what we're gonna do with the y is we're gonna get the ground hit.point. So if we hit here, this point, we're gonna push up by the player's height divided by 2. So it always makes sure that we are on top of the ground. Why did I divide by 20? I need to divide by 2. Okay. Now we're clamping on the ground perfectly, okay? But if it is smooth, we want to make sure we do it in a smooth fashion. So let's go transform the position equals vector3.lerp, and we're gonna go put in the same method here. So we're gonna copy this whole vector. We're gonna transform the position, and we're gonna put in this new vector3 and the smooth speed times time.delta time. We're gonna pass that in. Okay, easy stuff. And since we already found the collision transform that we were looking for, we do not need to loop further. So just to save some space and memory and make sure we don't stick to other things, we're gonna break out of that whole loop. Okay, now this is a prevention if statement to make sure that we clamp to the ground even if we accidentally clip through like this. For example, we're in the middle of here and here, and our actual player cannot decide which one is the actual ground. This little method here will just make a decision for it, and everything will be fine. So if we're going to get if num lower or equal to 1, and temp hit dot distance is lower than or equal to 3. Let's go 3.1f. Right. We're gonna go if col 0 is not equal to null. Ray equals new ray. Let me just I'll write down the code and then I will explain to you. And we're gonna go lift point vector3 dot down. We're gonna write to raycast hit if physics dot raycast ray out hit min grounding. This should be 3.1f and disclude the player. I'll explain this to you in a second. I'm sorry. Hit dot transform is not equal to col 0 dot trans grounded was false return Okay, so, oh, what is this? What did I do wrong? Okay, here we go. Okay, let me explain to you what this is. Okay, so, keep making mistakes. Okay, so we're gonna check if our collisions is less than 1. Okay, so if we have at least 1 collision. If it's not null, then we're gonna send a ray down again, right? And wherever that is, we're going to set it to that position, and we're gonna make sure we're grounded equal to false, so we start falling. So I don't know how to explain this to you, but if we're at a relatively small distance, right? Sometimes our player will ray down and then will check the sphere, but there's nothing there. And it will just stop. It won't be able to fall or anything. It will just get stuck, okay? So this is just a little if statement that makes sure you fall if there is no other colliders there. So, and it also helps with the wall sliding technique. So you see sometimes people have this issue with normal character controllers where they jump and then their player gets stuck against the wall. This is another little thing that makes sure that you don't get stuck against the wall. Okay, another quick little method that we're going to add here. And since we returned here, if this whole thing is satisfied, then it won't continue. And we're going to set grounded is equal to true here. Okay, and we're going to say if temp hit, oh, actually, I don't think we need this. Yes, we do not need this. Yeah, we don't need this. I'm sorry. I just need to make sure all of this is right, and this probably won't work, but we're going to try it, and then I'll come back and explain to you a general overview of how this controller is working. So, all of this, blah, blah, blah. Okay, we're going to make sure this works. It shouldn't work if we're going to set the player height. I'm going to make this 1 based on our scale here. And we're going to turn smooth off. We don't want smooth right now. And we're going to set the player to the ground position because sometimes that little point at the start of a game doesn't work properly. Oh, okay, so at least we're getting some results. We're in the ground a bit, so if we increase the player height to around 1.5, we can see that if I make it to 1.5, we are on top of the ground. So we just need to find the perfect player height. Okay, let's check the slopes, and boom, we have slope detection. Okay, so I'm glad it worked. I just want to explain to you now how it works. So let's just go in and set this to 1.6 because we know. Actually, no, is it still too much? Yeah. Let me set this to 2. Oh, yeah. I'm sorry. It has to be 2 because we're dividing this by 1 and it needs to be increased by 1. Okay. We're dividing the 2, sorry. Okay. So that's out of the way. We just check this now. And we have good. Oh, yes. I need to test the gravity as well. Okay, let me lift it. Drops. Perfect. We lift it. It drops, snaps to the ground, and you can see I'm holding onto the wire, pushing down, and we physically have to drag it through for a little while until it snaps because it's really powerful. Okay, but it's very nice and it's a good controller, and we've got all the basic features so far. Okay, so I need to explain this to you in an easy way. Okay, so firstly, we check if we are not grounded, and if we are, we add gravity, easy, right? And then our simple move, we add the smooth vector, and both of those things add up to create the velocity vector, and we multiply that by movement speed, turn that into our forward direction, and then we add our transform position to that in the time.delta time to make it smooth. Easy stuff. Okay, now this ground checking, right? We send a sphere cast down from the top of the player down to check if there is a ground, any ground at all, slope or anything. And if there is something in the midst of 20, we send a ground confirm check, okay? And in this, we add a collision buffer and we check all of the collisions at the bottom of the player. And if in that bottom of the player, we find the same object, ground object that we found in this sphere cast, in the collision buffer. We snap the player onto that collision. Okay, and here we check if we are against a wall or something, and if we are, then we just we just make sure that grounded is false, so we always fall even though we're on a wall. Okay, that's just a little prevention method over there. On my actual script, there is a way for you to traverse over smaller materials and stuff like that. There's just an extra 5 or 6 lines down here, which is not needed for our game at all. Okay, next order of business right now is cleaning up this really disgusting code. I don't like it at all. So we're just gonna just bunch up all of these private variables into its own little area. We're gonna call this grounded private variables, and I'm losing my voice. I'm really sorry. Okay, let's go back and let's set this into its own little region. So we're gonna call this gravity / grounding and end region. This is a really different way of handling grounding and gravity, but it's very nice. I honestly really like it myself. Okay, first we want to do collision checking. So collision checking is its own little beast on its own. A little beast on its own. Okay, don't worry about my English. Okay, private void collision check. Okay, this is one of the most important methods, arguably, in our whole game, and you are in for a ride, because I'm going to teach you some stuff you probably did not know. Collision check, okay. The way we're going to do this, okay, I want to explain to you. The last time in my old player control, the way I did this, right, was I sent a ray from here, hitting the wall, and then we got the wall's normal, and then we got a cross product of those two vectors, and we pushed it against the wall. That was the ugliest way I've ever done it, and that was when I was new to writing player controllers. Now I've written around like 20 player controllers because I have no life. And we're gonna start this. So basically how we're gonna do it now is what we're gonna do is we're gonna push the player up against it. Alright, and we're going to have a little sphere collider, or we're going to use the capsule collider itself, but I think we should use the sphere collider because it's more effective. But once we hit it, our method called physics.computePenetration is provided by Unity. I don't know if it's new or not because I've never seen it until like just a couple of weeks ago. So you see how it goes through the object slightly, right? So really, in reality, when we play the game, the frame rate would be so quick that it won't allow it to go this far in. But imagine that we go all the way through, right? It computes the penetration between the cube and this object right here. So it says, okay, well, how far are we into this cube? And it gives us a distance and a direction of what direction to push outwards in order to get it out of the cube. Okay, so this works for anything. It works with collision against sphere into sphere, mesh colliders into mesh colliders, anything. This method is like the best method I have found ever. Okay, and there's an easy way to make it really smooth and powerful. Okay, so first we're going to add a sphere collider, and what we're going to make sure we do with the sphere collider is not encapsulate the whole player. In fact, we only wanted to encapsulate half of our player, and 0.5, and at the top. So we have like this little head, if we can see this. It's just on top of the capsule collider. Okay, we really need this to be like this. Okay, once we had that, we're going to go into our script and go into our header and add references, and we're going to go public sphere collider, and we're going to go collider spherical. Okay, and then we're going to go out and quickly reference it because 99% of the time I get so caught up in the tutorial that I forget to do simple stuff like this. So I'm going to do that. We go back into our mono develop, and we're going to start our fun little collision check. And after that, we're going to do jumping, and then we're done for this episode. I'll see you next time. But until then, let's do this. We're going to create array overlaps plus new collider for. So this is basically the same technique that we used in our little grounding system here. In our ground confirm, we created a collision buffer and we checked the overlap sphere, except this time we're going to be doing it with a fake sphere type of thing. I mean, that time it was with a fake sphere, now we're going to use a real sphere. I'll show you how this works. Okay, so we're going to go into numbers, go physics, the overlap sphere non-allocate, transform point is sphere called at center. So spherical is the sphere collider, and the center, as you can see, is 0.5. But this is relative to the player's transform. So we need to make sure this is into world space. So it will turn the local space of 0.5 in the y00 into world space. Okay, that's extremely important. And then we're going to go sphere called radius. And this is useful because you can set the radius and everything in a visual way. So overlaps, we're going to reference our collision buffer here. And we're going to go disclude player because we don't want us detecting ourselves. We're going to query interactions use global. Okay, that's very important. Okay, now we're going to loop through again, but this time we're not going to stop it. We're going to loop through everything. So we're going to int I equals 0, I is lower than num, I plus plus. Okay, we're going to go transform T. I'm on the brink of losing my voice. Transform.T overlaps I. Transform, obviously this is like my 50th time recording the same video. And float dist. Okay, this is what I was explaining before. Transform T is our overlaps.transform. So let me go back to my little visual explanation here. Go wireframe. Okay, as you can see, this is the capsule cube here. Okay, so we are in here. The overlaps.t is this cube object here, and our distance, our dist float, is how far we went into the cube, and our direction is how we get out. Okay, that's how we do it. And now for the magic method, the most useful method that you will ever come across. If physics.compute penetration. Okay, it's a big method, but you'll get around to it. Okay, so spherical, you're going to pass in our collider. Collider A is our collider. We're going to pass in transform.position, our position, and our transform.rotation, and we're going to pass in our overlaps.I as our collider B. Okay, so as you can see, overlaps is a collider array, so we're just going to pass in the current collider, and then we're going to pass in t.position. So t is our overlaps object. So then we're going to pass in our t.rotation, and then we're going to pass out there and out dist. And basically this method has two outs, so it will automatically send you the distant direction without you having to calculate it. But if we didn't have this method, there is still a way to do it. You would have to get every single collider type, and you would have to figure out the maths. But this method just saves us a heap of time, and it comes built in with Unity. Okay, so we're going to call this the penetration vector. We're going to 0 times dist. Basically, this will give us a vector facing outwards and times it by the amount of distance that we've penetrated. So it will be perfect. It will be right here every single time. No clipping. We won't even see it. That's how amazing it is. And we're going to add a bit of velocity because we do need this. And we're going to go velocity projected is equal to vector3.project. I'll explain this. This is just a bit of vector maths. It's really useful. I just searched it up and learned it. And transform.position equals transform.position plus penetration vector. So here we just automatically set it to the penetration vector, but now we're going to modify the velocity just a bit. So we're going to go move. I don't know if we changed the move. I think we should create another private vector 3 called vel, and here we should just plus vel. I think that's how we should do it. And then we're going to change the vel here. Vel minus equals velocity projected. And once we do this, down here, at the end of final move, we're going to set vel is equal to vector 3, 0, 0. Okay, so basically what happens in this little line here, velocity projected, it gets our current velocity? No, that's not right, because velocity is set to 0 every time. Yeah, okay, no, this is right. So we get our current velocity, so the current direction we're moving in, and then we get the okay, I'm sorry. This is how it's going to work. We're basically going to get our current velocity, so imagine we're going this way, right? And then we're going to get our direction of the penetration inversed, so it'll be like this, right? And we're going to project the velocity onto the direction, so basically we'll get a vector where we're sliding across here. It'll be very minuscule, but if we do penetrate, we should be able to slide across, okay? So it's just a little extra. I don't really think you 100% even need it to make collision work very nicely, but it's needed. Projection is basically when you change the direction while keeping the distance, the length of one vector. I'm pretty sure that's what a projection of vectors is, but when I read it, it made sense. Okay, so let's check the collision, make sure everything is okay. I'm going to play this, and we're going to, a moment of truth, we're going to make sure we have the right angles. Okay, we're going to go in and, oh, okay, that was a bit, okay, no, that doesn't look right. I think it's 100% because of our projection that I was so confident about a second ago. What is going on? This should be working, actually. There. No, I don't think we need this for now. Let me just comment out these two lines. Like I said, it's not 100% necessary. I think it just helps with the velocity change, but it should, yeah, there we go. We have 100% working collision without that line. As you can see, it's very realistic, right? So if we're facing a bit in this direction or a bit in this direction, it slides. Okay, I'm only holding the W key, and I'm just trying to move forward. As you can see, it's gliding, but it doesn't work. It's amazing. It's actually amazing. It slides. Friction against walls can be implemented quite easily, but I'm not going to do that. But as you can see, I'm having quite complex collision, and now we have a nice smooth slope climbing process as well. We're going to jump off, and boom. Okay, how amazing this is. We have gravity, slope, and all of that. 100% self-implemented, no rigid bodies, no character controllers, and you know how it works. For the first time, you know how this works. Okay, now the last thing today before I lose my voice, because this recording is going great unlike the last ones. We're going to implement the jumping, collision, in the region. Boom, boom. Let's back into this. Spacing is very uneven. Don't like it. I'm going to create another region, variables. I'm going to end the region here. Boom. I'm just going to have region main methods. I highly recommend doing this on all of your scripts. It just keeps it organized because you don't have to see anything. You want to change your gravity, click into gravity, and you can change it. Okay. Now region jumping. Okay, I want to tell you something about the jumping. I did have quite some issues with the jumping, so we will have to change the script quite a bit to implement the jump. Okay, so we're going to create a private void jump, and there's an actual specific place where you have to put jump in order to make it work perfectly. So in your update, we're going to go here, and just underneath the simple move and above final move, we're going to add the jump. Okay, and we're going to go back into our jump method, and we're going to go bool can jump is equal to false. Okay, so we're going to go can jump is equal to negative physics.raycast. So you might have not seen a raycast been done like this before. Let me just explain to you what this is. You might always see if physics.raycast, if physics.raycast, but there's also heaps of other ways you can do it. But I'm going to add a little variable called, we're just going to use the player's height here. And I'll explain to you what this is. Okay, so basically what we're doing here is we're going to send a ray up, right, from the transformed position as a player.height, right? And what happens is if it detects something, right, then we can't jump, because imagine we have a roof. I hope you work. We have a roof right above your head. What this does is it raycasts up and makes sure there's no roof above your head. If there is, there's no point in jumping, because the only thing that's going to happen then is your camera is going to clip through and all sorts of ugly stuff is going to happen that you really don't want it to happen, okay? So I'm going to put this cube down and we're going to get back into our controller. That's basically what it is. So it's just a little check to make sure we can jump. And physics.raycast, this whole method actually returns a boolean. So it's actually really useful to just use it inline like that without having to do if physics or raycast and have its own little section for that. And we have to make sure that we're grounded in order to jump. Okay? And we have to add a private float. Of course we do. Private float jump height, and I set this to 0. And you might be wondering, wow, why would you want your jump height to be 0? Because jump height has nothing to do with the jump. Okay, jump height has everything to do with the current state of the jump and not how fast you can jump. But we're going to add the jump variables right now. So we're going to jump options, and we're going to public float jump force, public float jump speed, public float jump decrease. So let me explain this. Jump force, the force of your jump speed, how fast you implement that force. Jump decrease, how fast you start to fall. Start to fall, not how fast you fall. Okay, there's two big differences. Gravity is implemented when you start to fall. Okay, jump decrease detects when you should start falling. Okay, because you don't want to start falling as soon as you jump, because then you're not going to jump. Okay, easy stuff there, easy math. Not math, just logic. Okay, we're going to if grounded and jump height is greater than 0.2f. Ooh, this is great. Jump height is greater than 0.2f, or jump height is lower than equal to 0.2f, and then grounded. We're going to set the jump height to 0. We're going to put input. Okay, this is also a very important boolean that we have to add now. Input jump is equal to false. Okay, so basically, this little thing has nothing to do with the jumping. In fact, it has everything to do with if we are grounded, we should make sure that our jump height is 0. So we're not like bobbing up and down once we hit the ground. It's to make sure we stop jumping once we hit the ground. And what we're going to do is we're going to go into our movement method, and in our final method, we actually need to add the actual movement of the thing, of the jump. Okay, so minus current gravity plus jump height. Basically, the current jump height will be added onto the current gravity, and we will jump. Easy stuff, easy, easy, easy. Okay, we're gonna go back down to our jump, and I'm just thinking about this. Coming out this whole section here, and this section right here. Okay, and we're gonna create a little vector 3 here called vel, and we're going to go new vector 3, and we're going to go velocity.x, velocity.y, and velocity.z. I'm going to times this by movement speed, and instead of making velocity into the transform.transform direction, we're going to change the vel into the transform.transform direction. I'm so sorry, I made a slight mistake, but we should be on track right now. And we're going to set velocity to equal to vector 3.0. Okay, and we are on track. plus, and we're going to do transform dot plus equal to velocity. So what's going to happen here is we have this empty velocity vector, and we're going to modify the velocity vector every frame. So in the simple move, we're going to change the simple move first. We're going to go velocity plus equal to move. Okay, we're going to increase the velocity by that. Okay, and then we're going to go into our gravity dot grounding. We're going to go into gravity, and in our gravity, we're going to make sure if grounded dot is equal to false, we're going to go velocity dot y minus equals gravity. Okay, otherwise we're not going to do anything. Okay, that's easy. We can even keep kind of that little line there. Okay, we're just modifying the velocity wherever we go, and I really think now we can go back into our collision, and then we can change this to support projection again. So I think if we test this now, it should be working perfectly fine, even though we're using a completely different way of actually moving. So let me check this, and we should be able to still move, and we are working with collisions perfectly now, and there is a slight difference in the speed based on our direction. Okay, perfect. Okay, sorry, I made a slight mistake, but we're back on track now. Okay, now we're gonna go back to our jump. The jump actually makes sense now. I was wondering why none of it was making sense before, but it's fine. Okay, so let's go to if grounded and can jump input dot get key down. So we're just checking if we can actually jump. We're gonna go if you can get the key code dot space input jump is equal to true. Transform the position plus. I'll just explain this in a second. This is all just fine to tuning that I've done. Ground check radius actually. What is our ground check radius that we said before? 0.57, 0.6f. And we're gonna do times 2. So jump height. Let me just explain this once I write this. Okay, basically what we're doing, as soon as we press space for the first time, we're gonna give our player just the slightest boost off the ground. You won't notice it, but we need this because we need to make sure our ground isn't detected as soon as we jump. Because if that happens, then we'll get snapped straight back to the ground before we even jump. So we need to give it that initial boost above the radius of the check to make sure we don't snap back down. Okay, so if you can't jump and if not grounded, okay, so if you are unable to jump, so it makes you not grounded and you can't jump, right, and you would minus the jump height, right, by jump height times jump decrease times time dot delta time. So as soon as you're off the ground and you're jumping properly, your jump height will start to decrease by this amount. So your jump decrease times time dot delta time, so it gives us a smooth curved looking jump in the direction that you're moving. And at the end of the whole method, we're going to do velocity dot y plus equals jump height. Okay, there is like a couple of things that we do need to change in order to make sure that we are working this to the best of our ability. Okay, so sorry, let's go up to ground confirm, and in ground confirm we are going to here we're going to make sure if input jump is equal to false. We're going to go down here and we're going to make sure that's equal to false, and okay, yep, okay, sorry. And then input jump is equal to false. Okay, so this is basically why we did that, okay? If we're jumping, again, it's just prevention stuff. So if we're jumping, we don't want to snap to the ground, okay? That's self-explanatory. So this code snippet is for snapping, okay? And if we're not on the ground, we don't want to unnecessarily add extra force, okay? So if we are jumping, we don't want to add unnecessary force. Okay, but once we start to fall, this is the method. This is a little snippet that detects when we are starting to fall. Okay, so remember, when jump height is equal to 0, that's telling us that we're starting to fall. Okay, so here we check when we start to fall, then we turn this off, and then our gravity kicks in. So we need to make sure gravity doesn't kick in before our jump height is equal to 0. So that's why we're just setting all the stuff to input. We're going to make sure that input jump is actually greater than sorry, that's why we're going to make sure that input jump is false, so that gravity isn't acted upon before we actually reach the end of our jump. Okay, so obviously jump won't work now because we don't have the proper forces. So let me go in and add the force. Let me add a force of 4, jump decrease of 2, and I did not even use jump speed, but that's fine. As you can see, we jump and we have a perfect little jump. And as you can see, there is that little snapping at the beginning. No one will actually notice that because you can just dampen that with camera movement and all of that fun stuff. But as you can see, we have a perfect character controller. No sticking against the walls like we had with the CharacterMotor from Unity. We have perfect collisions, perfect slope detection. Everything is actually perfect. I'm actually quite surprised that it worked out this well in such a short amount of period. So, the first episode of the stealth game series, we've got a camera controller done, player controller done, slope detection, collision detection, jumping, everything that we need to start our basic game. And in the next episode, I have heaps of more fun stuff planned for you guys. Please subscribe and stay tuned to watch the rest of the videos. And thank you for watching, and leave a like, subscribe, and comment. And I'll see you next time.